So most mechanical engineers need to build CAD diagrams, and these are not very easy to make for frontier large language models. That is why we built the CAD Forge RLVE environment. So if you were to look at detailed docs, if you look at Opus, it generates CAD diagrams with large spaces in between and floating arms. Same with ChatGPT and same with DeepSeek version 4. Only Gemini does a very decent job at this. This is because they haven't been trained on an RLVE environment for long enough and there isn't enough data. So to do that, there were two main innovations that we did. The first innovation was to take any image and convert that image into a specific GLB file. So we did that by taking a sample CAD and converting that into a GLB file. For example, we start with a simple image like this, and then we use Meta's SAM3D to convert it into a reference GLB file, and then we use this as a reference to do the comparison between the final CAD model and the actual output shape. So that is one innovation, and the second innovation is where the environment fights back. So for that innovation, we'll have to have a look at the CAD Forge environment. Basically, when it fails, so you have all the links over here. I would strongly suggest reading a detailed blog, and I would also suggest waiting for a bit when this loads. So this is a weak seed, and this is a proper well-defined CAD model. So what we want to do is we basically observe failure whenever the LLM produces code. When it produces a failure that is not expected, we classify and bucket it, and then we create a new input trace and output trace, new reward model, and then we send it back to do GRPO. So for whichever samples it fails, it is able to train more on that and become better and better and solve that. So if you look at the issues, there are multiple issues that it can hit, and those issues are well detailed over here. It can be syntax closure, invented API, missing final fixture, floating parts, bad topology. So we drill down into what the model is weak at and we try to make it better. So that's how the environment fights back. We did 7 training runs. We did one SFT run with Qwen 3.5. We did one GRPO run, a dense run. We did again an SFT and a GRPO. For the SFT data, we used GPT 5.4 and we used its traces. Even though it's not the best, we use that as a benchmark so that Qwen can learn. And we have the final outputs as well. If you scroll to the absolute bottom, you can see our axial motor stator. This is how base Qwen does it. After fine-tuning and RL fine-tuning with GPT 5.4 SFT as well as GRPO, it's able to do a very good representation of the same model with a pretty good reward score of 0.65 and GPT 0.7. So it's getting very, very close to a very good way. So I believe we have succeeded.